Welcome to the optional course on water quality, focusing on biological characteristics. This presentation from ITM, Institución Universitaria, will explore the biological aspects of water quality. Raw water can contain a great diversity of microorganisms, some of which can be pathogenic. The most important microorganisms found in water that can cause diseases include bacteria, viruses, algae, fungi, and some protozoa. Common waterborne diseases include cholera, gastroenteritis, typhoid fever, dysentery, parasitism, hepatitis A, conjunctivitis, and others. Cholera is a diarrheal disease caused by the Vibrio cholerae bacterium. This bacteria is easily removed by conventional water treatment processes, so cholera is transmitted through consumption of untreated or poorly treated water. The disease was practically eradicated worldwide, but there was an outbreak in the early 1990s in developing countries with poor water systems and extreme poverty. Gastroenteritis is a generic name applied to diarrheal diseases that cannot be specifically classified. There is disagreement among researchers about the causative microorganism of gastroenteritis. However, it has been proven that several microorganisms can cause it. For example, Escherichia coli enteropathogenic produces gastroenteritis and frequently attacks children and the elderly. Algae can also produce gastrointestinal diseases, for example in livestock. Another example is Shigella-type Bacillus enterobacteria. Typhoid fever is a disease transmitted by Salmonella typhosa. It is transmitted through the fecal-oral route. The reservoir of this bacteria is humans, as it's an enterobacteria. Typhoid fever should not be confused with typhus, which is transmitted by Rickettsia bacteria through external parasites like lice. Throughout history, there have been devastating pandemics possibly caused by typhoid fever, including in Mexico in the 16th century with the arrival of the Spanish, and in Greece in 430 BC. Amebiasis, also called amoebic dysentery, is an intestinal disease that can produce bloody diarrhea, abdominal pain, and in severe cases, liver abscesses. It is a disease caused by Entamoeba histolytica, a protozoan or eukaryote. Bacteria are prokaryotes, meaning without a defined nucleus. The disease occurs through consumption of water or food contaminated with cysts of Entamoeba histolytica. For cyst removal, simple chlorination is not sufficient. Efficient removal requires an adequate potabilization process from the coagulation-flocculation phases. Giardiasis presents symptoms of watery diarrhea, gas, abdominal pain, nausea, and weight loss. Its transmission is oral-fecal through contaminated water or food or person-to-person contact. Cysts are ingested in contaminated water or food, then in the intestine, the active forms are released that adhere to the intestinal mucosa and alter nutrient absorption. The cysts are very resistant to chlorine, so to guarantee their removal during potabilization, efficient coagulation, flocculation, sedimentation, and filtration are required. The symptoms of cryptosporidiosis are watery diarrhea, abdominal pain, and mild fever. There is no completely effective cure for this disease. The disease is caused by a protozoan with the scientific name Cryptosporidium parvum that forms oocysts in contaminated water or food. The oocysts are more resistant to chlorine than those of Giardia and can even survive more than a week in chlorinated water. Let's compare three important protozoans: Giardia duodenalis, Cryptosporidium parvum, and Entamoeba histolytica. Giardia forms resistant cysts approximately 8 to 12 micrometers in size with high chlorine resistance, requiring UV, ozone, or boiling for conventional filtration efficiency. Cryptosporidium forms resistant oocysts approximately 4 to 6 micrometers with very high chlorine resistance, also requiring UV, ozone, or boiling. Entamoeba forms resistant cysts approximately 10 to 60 micrometers with high chlorine resistance, requiring antiprotozoal agents for conventional filtration efficiency. In conclusion, there are many microorganisms present in water that can cause diseases to consumers. Ideally, there would be a single pathogen that could be easily quantifiable. However, this is not reality. Therefore, in water quality, the coliform group has been selected as an indicator. Coliforms are characterized by being gram-negative bacteria in rod shape, non-spore-forming, fermenting lactose-producing gas and acid within 48 hours at 35 to 37 degrees Celsius, naturally found in the intestines of humans and animals, though some also in soil and vegetation, and easy to detect and quantify. The methods for coliform detection are multiple tube fermentation, or MPN, which stands for most probable number, membrane filtration and counting in selective media, and rapid methods with enzymatic kits. Coliforms can be classified as follows. Total coliforms are found in the environment, soil, vegetation, and feces, indicating possible environmental contamination or deficiency in disinfection. Fecal coliforms, also called thermotolerant coliforms, are found mainly in humans and intestines of warm-blooded animals, indicating recent fecal contamination. Escherichia coli, or E. coli, is found exclusively in human and animal intestines, also indicating recent fecal contamination. Coliform group bacteria are found in greater quantity and generally survive better in water than most pathogenic bacteria, though not always. Detection of pathogenic organisms requires much more sophisticated laboratory methods. The methods for coliform detection are multiple tube fermentation, or MPN, which stands for most probable number, membrane filtration and counting in selective media, and rapid methods with enzymatic kits. The most probable number method, or MPN, is one of the primary techniques for detecting coliforms in water samples. This method involves multiple tube fermentation to estimate the concentration of viable microorganisms in a sample. Membrane filtration is another key method for coliform detection. This technique involves filtering water samples through a membrane that captures bacteria, which are then counted after incubation on selective media. The coliform group is not the only indicator. Total streptococci are also used as fecal contamination indicators. Among the characteristics of this group, they are gram-positive bacteria in coccus form, and they present greater resistance to chlorine than coliforms. They also present greater resistance to salinity. The table compares fecal coliforms, E. coli, and enterococci streptococci. Fecal coliforms are gram-negative, indicate recent fecal contamination, have lower disinfection resistance, can multiply in the environment, and are used for potable water and general monitoring. E. coli is gram-negative, indicates recent fecal contamination, has high resistance, rarely multiplies environmentally, and is used for potable water. Enterococci streptococci are gram-positive, indicate fecal contamination and its persistence, have high resistance, rarely multiply environmentally, and are used for recreational waters and confirmatory fecal verification. For further reading on water quality and biological characteristics, please refer to the bibliographic references listed, including works by Sierra Ramirez on water quality evaluation and diagnosis, American Public Health Association methods for water analysis, Keeley on environmental engineering, Marin Galvin on physicochemistry and microbiology of aquatic environments, Mihelsik and Zimmerman on environmental engineering fundamentals, and Romero Rojas on water quality. Thank you very much for your attention. This presentation was brought to you by ITM, Institución Universitaria, in collaboration with Alcaldía de Medellín, District of Science, Technology, and Innovation.